Hello boys and girls, Mr. Giamini. I want to come to you with a couple of examples of how to solve multi-step equations. In this situation would be two-step equations. When we have integers involved. What I'm going to do is take these same problems over here and write them over here. So we have r divided by 20 plus 4 is equal to 5. Now, again, we need to start understanding the foundation, the algorithm for how to solve these. We can't always rely on guess and check. I'm going to guess some people can already solve this in their head, but again, I want to see the work, the evidence, because that way when we get to more complex problems, you'll have that to fall back onto. It'll make the more complex easier if we can solve these. First thing I notice is we have this r as our dividend with 10 as our divisor. We can kind of think that these two things are joined together. So right now I'm just going to box these in. I'm not going to mess with this just yet. Now remember, we have an equation. We have a left side of the equation and a right side of the equation. I always want to have a balance. Whatever I do to one side, I must do to the other. I can't ever have one side be completely just empty. So because I'm going to just hold off on this because of the variable here, I'm going to now take a look at this plus 4. I want to get rid of the adding 4 because, again, I want to focus on this r here, but to focus on the r divided by 10, I must get rid of the plus 4. Well, the inverse of adding 4 is to subtract 4. And let's recall, whatever I do to one side of the equation, I must do to the other. Great thing about this, hey, r divided by 10 just comes straight back down. 4 minus 4, those cancel out. We're left with nothing. I'm not going to bring the 0 down because I don't need to be confused by that. It's just gone. It's empty. We have 5 minus 4 gives us 1. All right, now we can focus on this r and the divided by 10. Now that we got rid of this extra kind of wheel here, we can get rid of this divided by 10. Well, again, I want to get rid of the divide by 10. I want to undo the division of 10, so to undo this is to multiply. Now I'm going to make it look like a fraction here because this is a fraction. This shows me that these cross out. So now I'm just left with 1. I'm left with 1r equals. Whatever I do to one side, I must do to the other. Because this is a whole number 1, I'm just going to multiply by the whole number of 10 over 1, which is 10. 1 times 10 gives me 10. So there's my final answer. Now remember, I can always check this by substituting in what I found r to equal back into the original equation. And if we did this in our heads, 10 divided by 10 is 1. 1 plus 4 gives us 5. Hey, that is a check. That equation works. So my solution of 10 is the correct solution for r. I'm going to erase this. Let's take a look at the next problem. We have 3 p's. So 3 times p minus 2 is equal to negative 29. Again, I have something on the left side of the equation. I have something on the right side of the equation. I must keep something on both sides. First thing here, I notice I have two terms. I have term 1 and term 2. Term 1 has the variable of p. Because term 2 has no variable, I'm going to attack this part first. Now, I see we're subtracting 2. Well, to get rid of minus 2, if you have $2 in debt, I'm going to add $2. So now you would have no debt. Whatever I do to one side, I must do to the other. This is now canceled out. I will bring down that 3p. So 3 times something equals, now we have negative 29 plus 2. I'm at negative 29, I add 2 to it, so I'm moving 2 closer to 0. So if I'm at 29, I add 2 to it, I'm now at negative 27. I now can evaluate for 1p. I don't care. I know that 3p is equal to negative 27. My goal here is to find out what 1p is. So the inverse of multiplying by 3 would be to divide by 3. So 3 becomes our divisor for both sides of the equation. These cancel out. I'm left with p is equal to negative 27 divided by 3 gives me negative 9. And again, the way to check this is to substitute in back into the equation. Negative 9 times 3 gives me negative 27. Negative 27 minus 2, so I'm at negative 27. It just drops 2 more degrees. We're now at negative 29. Let's take a look at the next one. Hope this is starting to kind of sink in a little bit of how we need to work these algorithms, how this becomes a step-by-step. It's very methodical. There's a reason for everything we do, not just kind of I'm going to guess and try this. We have k minus 10, divided by 2 equals negative 7. Now, right now, we have the k minus 10 divided by 2. In the previous problem, we had 2 terms. Up here, we had 2 terms. Here, it looks to be like I have 1 term. Well, I want to get rid of this divided by 2 so I can have this k and 10 kind of isolated on the left side by themselves. Well, this is saying, hey, divide everything up top by 2. Well, the inverse of dividing by 2 is to multiply by 2. I'm going to make it look like a fraction. That way when I cross reduce, I'm just left with 1, so I have k minus 10. Whatever I do to one side of the equation, I must do to the other. Because this is an integer of negative 7, I'm going to just multiply by the integer of 2. I don't need to make it a fraction. So we have negative 7 times 2 gives me negative 14. Alright, now I have two terms. I have the k and I have the 10. I want to isolate that k by itself. So right now, let's get the k by itself. To get it by itself, we need to get rid of this minus 10. Well, the inverse of subtracting 10 is to add 10. Whatever I do to one side, I must do to the other side. We are gone now from here. Gives us 0. Leaves with just that k, which is what I want. Negative 14 plus 10. It's negative 14 out. It raises 10 degrees, so we're not back at 0 yet. We're still at negative 4. If I substitute that back in, we now have negative 4 minus 10 divided by 2, we would hope equals negative 7. Well, negative 4 minus 10 gives you negative 14. Negative 14 divided by 2 gives you negative 7. So we have k equals negative 4. I feel confident in the answer. I just checked it through. I'm going to erase this. Final problem. We have negative 9 plus n divided by 4 equals negative 7. I now have two terms over here. I have a plus sign separates this term from this term. Which one of these terms has the variable? The second term. We will not deal with the second term yet. We'll deal with this negative 9. Well, if I have negative 9 here, I'm $9 in debt. I want to get rid of my debt, so I'm going to add 9. Whatever I do to one side of the equation, I must do to the other side of the equation. Draw my equals bar. This cancels out. Leaves me with the n divided by 4 is equal to, now we have negative 7 plus 9. Signs are opposite, and I'm adding integers. So instead of adding, I'm going to subtract. 9 minus 7 is 2. 9 had the larger absolute value. It was a positive number, so my answer will stay positive. Now I need to get rid of that divide by 4, because this line here, we think about it as a fraction. It also means divide. Well, rather than dividing by 4, I want to multiply both sides by 4. I'm going to do that whole number there. That gives us the crossing out, the cross reduction, leaving us just as the n. Whatever I do to one side, I must do to the other. So we have 2 times 4 will give me 8. If I substitute 8 back into the original equation, 8 divided by 4 is 2. Negative 9 plus 2 gives me negative 7. I feel confident in my answer. Hope this helps you out. Take care.